Let's look at another example of graphing a quadratic function. This time we have h of x equals 4x minus x squared minus 1. When I see an equation like this, the first thing I'm thinking is that it's not in standard form, so I want to rewrite it so that it is in standard form. So I'm just going to rearrange the terms. So instead of 4x minus x squared, I'm going to make it negative x squared and then plus 4x minus 1. Remember that the operation of subtraction is the same as saying the opposite of x squared, and so we want to keep that sign with the term. Let's look at which direction the graph opens, the line of symmetry, the vertex, and then after that we're going to look at the intercepts, so the y-intercept and the x-intercepts. And then we will look at the maximum and minimum value, well, it's maximum or minimum value, and where it's increasing, decreasing, positive, negative, and the domain and range as well. So we can tell if the graph opens up or down by looking at the leading coefficient. The leading coefficient in this case is a -1. Since a is -1, this parabola opens down. The line of symmetry is found by doing x equals opposite b over 2a. So let's look at that. X equals, the opposite of b would be -4 over 2 times a, so 2 times -1 would be -4 over -2. So our line of symmetry will be x equals 2. For the vertex, we're going to take that x value of 2 and we'll keep that for our x coordinate, but then to find the y coordinate we're going to have to substitute 2 into the original equation. So we'll be plugging in 2 for this x, so y will equal -2 squared plus 4 times 2 minus 1. Now keep in mind your order of operations. This says the opposite of x squared, and we've got to do that squared first before we do the opposite. So I'm going to be doing 2 squared first, which will give me 4, and then make it the opposite. So it will be -4 plus the 4 times 2, which is 8, and then minus 1. So the y value will be -4 plus 8 is 4, and then 4 minus 1 is 3. So 2, 3 is the vertex. The y-intercept is found by putting in 0 for the x value. So when it's in standard form the way that is, it will be at 0, c, and c in this equation is -1, so the y-intercept will be at 0, -1. And the x-intercepts we find by setting the equation equal to 0. So we'll have 0 equals -x squared plus 4x minus 1. And we can solve that by factoring or completing the square or the quadratic formula. This doesn't look like it's going to be easy to factor, so we could either complete the square or do the quadratic formula. I'm going to go ahead and complete the square this time, I think. So I want to get all my x terms onto one side, and I know I want my leading coefficient to be a 1, so I'm going to go ahead and move those to the left side, which will give me a positive leading coefficient. So now I have x squared minus 4x, leave a space, equals -1. And then I've got to find half of -4. So off to the side I'm thinking -4 divided by 2 is -2. I square that. That gives me 4, and that's what I'm adding to both sides. So plus 4 plus 4. Factor the left side. X minus 2 squared equals 3. And take the square root of both sides. gives me x minus 2 equals plus or minus the square root of 3. And then add the 2 in, so I get x equals 2 plus or minus the square root of 3. That's kind of an odd look for an x-intercept, but that's what it is. We have x equals 2 plus the square root of 3, comma 0, and then we have x equals 2 minus the square root of 3, comma 0. Those are my x-intercepts. Now, in order to be able to graph those, I'm going to have to get a decimal approximation. I don't know how to graph 2 plus the square root of 3. So I'm going to do the approximate symbol here, approximately equal to, and I'm going to use my calculator to figure out that 2 plus the square root of 3 is approximately 3.7. I'm not going to graph any more accurately than that, so I'll just say 3.70, and then I also need to do 2 minus the square root of 3. Oh, I have that blob in front. I better calculate that again just to make sure. Probably about 0.30 is all the more accurate I'm going to get. So on my graph, I'm going to put all of this information. The vertex is at 2, 3. The y-intercept is at 0, negative 1. And the x-intercepts are at 3.7, 1, 2, 3.7, and 0.3. Okay. That doesn't give me a whole lot of information, but remember, I'm also going to look at is there a stretch or compression, and I look at that on my leading coefficient, which is negative 1. So I think, is there a stretch or compression? A is negative 1, which means it's not stretching, but it is upside down, or it opens down. So my pattern is going to be over 1 and then down 1, over 2, down 4, over 3, down 9. So starting from my vertex, we'll go over 1, down 1, over 2, down 1, 2, 3, 4, over 2, 1, 2, 3, 4, oh, right on my y-intercept, and then over 3, down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, down there, and then over 3, down 1, 2, 3, 4, 5, 6, 7, 8, 9. So that gives me a nice picture of my parabola. Now let's answer some questions about this parabola. Let's start off with domain and range. Domain is an easy question to answer for parabolas. The domain for a parabola is always negative infinity to infinity. Now the range is going to be different depending on if the parabola opens up or down. We always want to start from the bottom of the graph and see if the function is defined down there. So this graph does have pieces down at negative infinity, so the range will go from negative infinity up to the top value right here, which happens to be 3. So this range will be negative infinity up to 3. And that brings up a good point about whether this graph has a max or min. Does this graph have a maximum value or a minimum value? This graph has a maximum because it gets up to the top point and then turns back around and starts heading downhill again. So it has a maximum, and the value of the maximum is, that's always the highest y value it reaches. So the highest y value it gets to is 3. So it has a value maximum, and the value of the maximum is 3. Let's look at increasing, decreasing, positive, and negative. Increasing means the graph is going uphill. Decreasing means the graph is going downhill. So as I move from negative infinity on the x-axis to positive infinity, when I start out all the way at the left-hand side, you can see that the graph would be going uphill. So it's going uphill as I move left to right until it gets to this top value, and then the graph turns around and starts going downhill. So the graph is going uphill from negative infinity to this x value right here, which is 2. And then it's going downhill or decreasing 2 to infinity. So increasing negative infinity to 2 and decreasing 2 to infinity. Positive and negative. Positive means above the x-axis. Negative means below the x-axis. So if we look at where is this graph above the x-axis or positive, it is above the x-axis in between these two x-intercepts. So it's positive from this x-intercept, which is the approximately 0.3, all the way over to this x-intercept, which is approximately 3.7. So we'll say that it is positive from, I'm going to use the exact form, so 2 minus the square root of 3, up until the x value of 2 plus the square root of 3. And then it's negative between negative infinity and that first x-intercept. So negative from negative infinity to 2 minus square root of 3. And then in between the x values, they're x-intercepts, they're positive. So then it's negative again from this x-intercept of 2 plus the square root of 3, all the way for the rest of the graph, so all the way over to infinity.